Basically, trigonometry is the study of angles, okay? We are starting with right-angled trigonometry, which means we are only dealing with right triangles in like this particular section. Right triangle, by definition, is that you have a right angle in your triangle. You can only have at most one right angle in your triangle. Why is that? So my right triangles will only have one, which means this is very easy to see what are my legs and what is my hypotenuse. So your legs of your triangle are the two that make up that right angle. And then your hypotenuse is the guy that's opposite, always your longest angle. So there's some ratios that happen with right triangles. And that's where trigonometry comes from. Trigonometry is basically just telling you the ratio between the sides, okay? So if I wanted to know the ratio between the sides, comparing it for this angle A, there's a certain ratio that always happens between the opposite and the hypotenuse side. There's a ratio that always happens between the opposite and the adjacent side. And so that's where we get our right angle trig. What you're telling me when you tell me one of the trig functions, you're literally just saying the ratio between these two sides is this for this measurement of an angle. And it doesn't matter how large the triangle is, the ratios will be the same for a specific angle. So if I have a 30-degree angle, the ratio between the opposite side and the hypotenuse side will always be 1/2. For any 30-degree angle. It doesn't matter if my triangle is small enough to draw on a piece of paper or if I'm triangulating a satellite dish with a 30-degree angle. The ratio between the sides of that triangle will always be the same if it is a 30-degree angle. And so this is what they actually use to triangulate when they're doing road work, when they're doing, when they are placing satellites, they're using triangulation methods with trigonometry. And so that's one of the reasons I actually love it so much. You'll notice that it has a little picture in your book. Oceanographers use trigonometry to model ocean waves, which is pretty interesting to me. So we're going to do some modeling. We're going to do some word problems, but we're going to start out with something that's rather familiar. All right. Your basic trig, your basic first three trig functions are sine, cosine, and tangent. All right. In the geometry world, hopefully this is a little bit familiar because in geometry, we just abbreviate it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right. Now, so the little abbreviation or shortcut SOHCAHTOA, if you hear that, it's to help you remember what those relationships are. It is in reference to an angle, meaning your sine, cosine, and tangent will change depending on what angle you're talking about. So the first key step in right angle trigonometry is making sure you label your triangle correctly. If I am talking specifically about angle A, then I am going to have specific, opposite, adjacent, and hypotenuse. Opposite of A is going to be this side over here. Adjacent of A, well, that's always going to be the side that's touching it. Hypotenuse doesn't change depending on the angle. Hypotenuse is always the hypotenuse. But that is in reference to angle A. If I wanted then to look at angle B and label, my triangle would be different. My hypotenuse would be the same because hypotenuse never changes. But all of a sudden, opposite would be over here and adjacent would be right here. When you think of opposite, you stand in the corner that you're talking about and walk across the triangle and you'll hit your opposite side. All right? Hypotenuse is always your longest side, the side opposite your right angle, and adjacent is the one that's left over. It's the one that's actually made by the angle itself. And so it depends on which angle you're talking about as to which side is labeled which way. But once you have your sides labeled, you've got the rest of the thing already figured out. So let's look at example 1. State the 3 basic trig ratios of these angles. The first angle I'm talking about is the angle S. All right. So if I want the sine of S, and by the way, sine is shortened without that E. Cosine is shortened to just COS. And tangent is shortened to TAN. The first thing I have to do is look at my angle S and label my triangle. This is angle S, which means opposite, adjacent, hypotenuse does not change. So if it's asking for the sine, it is asking for the ratio between the sides. Remember, sine is opposite over hypotenuse. So I'm going to find my opposite side, that's 12, over my hypotenuse, which is 13. That is the ratio between the sides. If I want cosine, remember cosine is adjacent over hypotenuse. Then I'm going to say adjacent to angle S over the hypotenuse. And then if I want tangent, that is the opposite side over the adjacent. Opposite side was 12, adjacent side is 5. Now in your calculator, if you do a sine, cosine, and tangent, it's not going to give you a fraction. Typically, it's going to give you a decimal. So if you were to take 12 and divide it by 13 in your calculator, you're going to get a decimal. That decimal is just giving you the ratio between the sides. That's all it's doing. It's just giving it to you in decimal form. And so in your calculator, it's going to give you this huge decimal. Keep in mind, it is just representing what happens when you do one side compared to another in a right triangle. The next thing they did is they asked for angle T. Well, now if I look at angle T, my sides are going to change. Hypotenuse will not. This will still be my hypotenuse. But now this side will be my opposite. This side will be my adjacent. And so my sine, cosine, and tangent of T are going to look like this. What do you notice about the sine, cosine, and tangent of T compared to the sine, cosine, and tangent of S? What do you notice about those? So basically when I look at these, the sine of S is the cosine of T, right? The cosine of S is the sine of T. What do you notice about the tangents? They are reciprocals of each other, right? This will always be true of complementary angles. Pulling from your memory, what is a complementary angle? What are complementary angles? Yeah, they add up to 90 degrees. Why would S and T add up to 90 degrees? So in a triangle, my angles always add up to 180, right? This guy takes 90 of it away, which means these two must always add up to 90. They will always be complementary angles. So in a right triangle, your cosine and sine will always flip-flop for your two angles that are left over, and your tangents will always reciprocate, always, because they are complementary angles, and complementary angles will always do that, always. So SOHCAHTOA is how you're going to remember sine, cosine, and tangent. Then you have reciprocal functions of those. Cosecant is the reciprocal of sine. I did not choose that. I would have made him the reciprocal of cosine, just so you know. But he's not, okay? So the cosecant is the reciprocal of sine, meaning if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. You just flip it upside down, all right? Secant is the reciprocal of cosine. If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And then cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. Here's the thing. All you really have to do is remember the first three and then just find them and flip them upside down if you want to find the other three, right? And so if you're trying to find all six, I always start with the first three. Then I write the other ones to the right of it and I just flip them all upside down. So for example, they want us to find the exact 6 trig functions of the angle H. So I'm talking about this angle. The first thing I'm going to do is I'm going to label my sides. Hypotenuse is easy. He's always opposite of my right angle. My opposite side of H is going to be over here, and my adjacent side is going to be right here. What do you notice about this triangle? What's the length of my opposite side? They did not give it to me. It is a right triangle. I have 2 of the 3 sides. I should be able to figure out the third side. What method do I use? Pythagorean theorem. So I can say, well, a squared, that's going to be 1 squared, plus b squared, which I do not know, should equal c squared, which is my hypotenuse squared, right? So I have 1 plus b squared equals 4. B squared equals 3. What is b? square root of 3. In a right triangle trig, you will not have a negative. We're going to get into trig that you will, but in right angle trig, you're not going to have a negative because we're talking about the length of a side, okay? So my opposite side then is the square root of 3. Now I have all three sides, and I can just write my trig functions, all right? So my sine then, my sine of h is going to be opposite square root of 3 over hypotenuse. My cosine of h, that's going to be adjacent, which is 1 over hypotenuse, which is 2. Tangent of h, that's going to be opposite square root of 3 over adjacent, which is 1. We're going to reduce that to square root of 3. All right? It wants all 6 of them. So what I do is I write my reciprocals to the right of it. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. All I do is flip them. So if sine is square root of 3 over 2, cosecant is 2 over the square root of 3. If cosine is h, then secant is 2 over 1. If tangent is square root of 3 over 1, then cotangent is 1 over the square root of 3. The only thing I need to do here is what I did in bell work. Right here, I have a square root of 3. What do you think I'm going to do with that? Yeah, I'm not going to leave it in the denominator, so I do need to rationalize these. So I need to take that square root of 3 and multiply the top and bottom by the square root of 3. So I have 2 square root of 3 over 3. 2 over 1, probably not going to leave it like that. How do you think I'm going to do that one?
2.
Just a 2. And then I'm going to rationalize this guy as well. Square root of 3 over 3. All right, so once you know the first 3, the other 3 are easy to find. Just flip them upside down. And you may need to simplify, but that's true of all trig functions. Simplify it. You'll notice that I'm not giving a decimal here. If I ask for exact values, that means I want fraction and rational form. If it says round, you would put it into your calculator and you would actually give me a decimal form, all right? Exact means fraction, all right? They didn't actually give me a triangle here. They just gave me some information. It says, given acute angle alpha such that tangent of alpha is 0.6, find the 5 other trigonometric ratios of alpha. State each ratio as both an exact value and a decimal approximation. So here's the thing. They gave me one trig function, all right? So what I'm going to do is I am going to draw a triangle based on that trig function that they gave me. I'm going to draw, well, if it'll let me draw, I'm going to draw a regular right triangle. And then I'm just going to label one side alpha. So obviously this is my right triangle, and I'm just going to label an alpha. All right. They gave me the tangent of alpha, which is one of my trig functions, as 0.6. Well, if I want to use right angle trigonometry, it's probably going to be easier to write that as a fraction. Thankfully, they gave me a really easy decimal to write as a fraction. 0.6 is just 6 over 10. I'm going to reduce that to 3 over 5, all right? Now I have to think about with tangent, what does this 3 over 5 represent? Well, tangent is what two sides? Yeah, it's opposite over adjacent. So I know the opposite of alpha over here should be 3. The adjacent of alpha, which is right here, should be 5. If I'm supposed to give all 3 trig functions, what do I need to solve for before I start? My hypotenuse. And so I'm going to use Pythagorean theorem to do that. 3 squared plus 5 squared equals c squared. So 9 plus 25 equals c squared. 34 equals c squared. C squared is the square root of 34. So I have my 3 sides. They are labeled opposite, adjacent, and of course this is hypotenuse. And so I'm ready to write my trig functions. The sine then of alpha, this is easy now. I have opposite, which is 3 over the square root of 34. Cosine of alpha is adjacent over hypotenuse. Then my cosecant, that's just going to reciprocate my sine, square root of 34 over 3. Secant is just going to reciprocate my cosine, square root of 34 over 5. And tangent is just going to cotangent rather, is just going to reciprocate my tangent. That's just going to be 5 over 3. I do need to rationalize these, so I do need to simplify those. That would be like leaving it without reducing a fraction, so we do want to simplify those. All right, those are my fraction forms. It also wanted decimal approximations. How would I do decimal approximations? Plug it into your calculator. It doesn't tell you how to round. I will say they usually round trig functions to 4 decimal places. And so if you'll notice in your book, they put all of these into the calculator and rounded to 4, but I'll typically tell you what to do. So in your larger calculators, there's 2 modes for doing trig functions. The first mode is degree. And so degree is exactly what you've always known with angles. It's how you measure an angle, one of the ways. The other one is radians, which we are going to get into radians in this chapter. But if your calculator's in the wrong mode, you're going to get the wrong answer. And so you always want to check and make sure you're in the right mode. I always do it with an angle that I know. So the sine of 30 is always 0.5. So you can very quickly check to see if you are in angle or radian by just doing sine 30, enter. If you get 0.5, you are in angle, not radian, okay? And so I have had people take the entire test in the wrong mode. That is a bad day when you go to grade a test and they were in the wrong mode. So I tell you over and over, check your mode and make sure you are in the mode that you want to be in, okay? Because it will give you an entirely different answer if you are in a different mode. All right, it's like measuring in meters versus feet. All right, you're going to give me the wrong answer if you measure in the wrong one, and that's what this is doing. So make sure when you put in sine of 60 degrees that you get 0.8660. All right, if you do not, if you get some other answer, you are not in degrees. All right, so I just want you to check these and make sure that you are getting the right answer for these. Sine is going to be 0.8660. Tangent is going to be 0.4163. Let's talk about secant. What is secant? Well, it's the reciprocal of cosine. Cosine. In your calculators, it means you are either going to have to find sine and do the reciprocal, which is not the button above sine, all right? Inverse sine is not the same thing as reciprocal sine. Or, because sometimes you do have a reciprocal button on your calculator, you can just say 1 divided by the sine of 83.25. So in your calculators, to do something like this, you would say 1 divided by the sine of 83.25, all right? Oh, sorry, cosine. After we just said that, yeah. Cosine. So 1 divided by the cosine. Do not do the button above cosine. All right, we're going to do that finding angles in a minute, but that's not reciprocal. So 1 divided by. 1 divided by. Or you may have an x to the -1 button on your calculator. That is reciprocal of x, all right? So if on your calculator on that left-hand side you have an x to the -1, you can actually do your cosine and then do that button and it'll reciprocate it for you. Either way, you should get approximately 8.5079 when you round it. So solving a triangle literally just means finding all of your angles and sides of the triangle, all right? So we are now going to look at your inverse functions. On your calculator, you will see sine, cosine, and tangent. Those are giving me the ratios. So those I actually say, here is 60 degrees. What is the ratio between the opposite and hypotenuse sides? That is your sine, all right? So when I give you 60 degrees and I say, what is the sine of 60 degrees? You would say, well, the sine of 60 degrees is square root of 3/2. That happens to be the ratio of 60 degrees, all right? So that is the ratio. You are giving me the ratio and I have given you the angle, all right? So when you are using those 3 buttons, sine, cosine, and tangent, or when you are gleaning it from a right triangle, you are giving me the ratio, all right? There are times, however, when I'm going to hand you the ratio and I'm going to say, what is the angle, all right? So instead of giving you the angle and asking for the ratio, it's going to be flipped. I'm going to say, here's the ratio. What angle gives you that ratio? That is the inverse sine, all right? And so that's where we use these buttons right here. Inverse sine is what you're going to use to solve for the angle. If you're solving for the ratio, then you are solving for sine, cosine, tangent, cosecant, secant, cotangent. But if you are solving for the angle, you are using your inverse functions. And so the inverse functions on your calculator are listed right above your functions. They look like this in your calculator. You will only use these when you are trying to figure out what the angle is, all right? So they give the definition. If the sine of alpha is x, then the inverse sine of x is alpha. They cancel each other out, just like any inverse functions, right? Addition cancels out subtraction. Multiplication cancels out division. Sine will cancel out inverse sine. All right? If the cosine of alpha is x, then the inverse cosine of x is alpha. Same for tangent. So they've given us this example. The sine of 60 is square root of 3 over 2. The inverse sine of square root of 3 over 2 then is 60. So if you were given a triangle and they want you to solve for the angle, you're going to back into it using your inverse. All right? Let's look at examples. Find the acute angle whose sine is 3 over 10. All right? So they gave me the sine of 3 over 10. 3 here would be the opposite. 10 here would be the hypotenuse. This is the angle. All right? So that means the sine of alpha is 3 over 10. If I then want to solve for what the angle actually is, if I'm solving for that angle measure, then in my calculator, I'm going to do the inverse sine of 3 over 10, or 0.3, or if you have a fraction that is not that easy to decimal, just do 3 divided by 10 in parentheses. So in your calculator, you're going to use your second button, right? Your second or your shift, all right? And then you are going to put in sine. So go ahead and try that. Use your shift or second button on sine. It should open parentheses. You want to do 3 divided by 10 or 0.3, close parentheses. And then you're going to round your degrees to the nearest tenth, 1 decimal place here. When you have something like this and it says solve the triangle, what it is telling you to do is give me every angle measure and every side length, okay? So typically what I do is I write it out. I say, well, angle A is what I'm looking for, angle B I'm looking for, angle C I already know. What's my degree measure of angle C? They give it to me with that little note, 90 degrees. Then I need side A. I actually have side A. It is 4. Side B. They actually gave me side B. That is 7. Side C. How do I solve for side C? Pythagorean theorem. All right. So I'm going to say, well, I'll start with C because before I can do my trig functions, I need to figure out what my hypotenuse is. So 4 squared plus 7 squared equals C squared. 16 plus 49 equals C squared. C squared is going to equal 65. C will be the square root of 65. That is 5 and 13. It doesn't simplify, so C is the square root of 65. We're just going to leave him like that. All right? So now I want to find my other 2 angles. All right? Angle A. I can use sine for all of these, right? To find angle A, I would put into my calculator the inverse sine of what? Inverse sine of what? If this is A, what am I going to put into my calculator? Sine is what 2 sides? Opposite over?
Adjacent.
Yep, so opposite over hypotenuse, which we just figured out was the square root of 65. So in your calculator, you would say inverse sine of 4 divided by square root of 65, right? Yes? If I wanted angle B, do I need to actually use a trig function here if I find angle A? There's 2 ways to find angle B. What are they?
Subtract.
You can just subtract, all right? So go ahead and find angle A. What is angle A? There are multiple ways to find angle A too, by the way. Yeah, so you should get about 29.7. You could have also used inverse tangent if you'd wanted to, right? Inverse tangent. You could have been inverse tangent of 4 over 7. Inverse cosine of 7 over square root of 65. Multiple ways to find angle A. Angle B, personally, if I were doing angle B, I would say what? If I'm using subtraction, what will A and B always add up to? We said this already. They're what type of angles? Complementary angles. So if I have A to find B, what can I do? Subtract from 90, right? So I can just say, well, this is just going to be 90 minus 29.7. I don't have to do any trig there. I can literally just subtract. All right, 60.3. Once you have all three angles and all three sides, you have solved the triangle. All right, you have solved the triangle when you have all three angles and all three sides. Questions on solving a triangle? Yes?
So you use the inverse when, like...
To find an angle. Anytime you're finding an angle, you're going to use an inverse trig function, okay? If like at B, I didn't need to because I had 2 out of 3 angles. So when you have 2 out of 3, any of a triangle, you don't need to use trig. You can just subtract. But if I have 2 missing angles, I'm going to use an inverse trig function. And you can use whichever inverse trig function you want to, depending on what side you have. All right? So anytime you're solving for an angle, you're going to use an inverse trig function. If you're solving for a side, you're going to use a trig, a regular trig, not inverse trig. All right? So let's look at these. We won't do special right triangles just yet. We also did this a little bit in geometry. Angle of depression versus angle of elevation. All right, this is always in reference to the horizontal. By that I mean, if I am talking about angle of elevation, it is compared to looking straight ahead versus looking up, all right? If I'm talking about the angle of depression, it is talking about the angle compared to the horizontal, looking straight ahead and going down, all right? And so you create angles of depression. If you're at the top of a tower like this, his angle of depression would be the horizontal compared to how far he looks down. Angle of elevation is going to be the horizontal compared to how much he looks up. Something else to note about these are parallel lines, right? Horizontals to the line of sight, those are going to be parallel, which means this guy's angle of elevation will equal this guy's angle of depression because they are alternate interior angles. That is pulling way back from your memory in geometry. 2 parallel lines. This is the transversal, the line of sight between them. So if you were to do a word problem and you're like, angle of depression is confusing me, drop it and flip it to angle of elevation. It's the same angle. So the angle at which I look at Lewis is going to be the same angle at which Lewis looks at me. Those are going to be the same angles, okay? His horizontal up, my horizontal down will be the same angle because those create parallel lines, all right? So when you look at this from a spot 75 feet from the base of a building, an engineer used a transit to determine the angle of elevation to the top of the building measures 67 degrees. If the transit is 5 feet high, find the height of the building, all right? So the first thing you want to do with these is draw a picture, all right? 75 feet from the base. That's a key word. That's the base of your angle, okay? Angle of elevation from here then is 67 degrees, all right? If the transit is 5 feet high, find the height of the building. Why did they tell me 5 feet? Well, my right angle is going to give me this guy from the actual ground, though it started at 5 feet. So I'm going to use right angle trigonometry to find that x, and then I'm going to add that 5 feet to it. That's why they gave me that extra piece of information. All right. So when I have something like this, I have a really simple right triangle. This is my angle. So x is what? Opposite, adjacent, or hypotenuse. What side is x? From 67 degrees, it is opposite. 75 then is adjacent. All right. What of my main 3 trig functions deals with opposite and adjacent? Tangent. So the tangent of 67 degrees should equal my opposite side over my adjacent side. That is a very basic algebra problem. How do I solve for x?
Cross multiply.
Yeah, and it's basically a division that's going on, so you can just multiply. If I multiply both sides by 75, right, I will get x. So in your calculators, do 75 times the tangent of 67 degrees. We're going to round to one decimal place. 75 times the tangent of 67 degrees. You should get approximately 167.7 feet. Am I done? How high was he off the ground already?
5 feet.
That's where this comes into play. So I need to do that. That's how tall the building is.